In this question, we're given a couple of half reactions, and then we're asked a series of questions, including what reaction happens at the cathode, what reaction happens at the anode, the overall balanced equation, and whether or not we can determine the reduction potential for this cell. And it's going to probably be easiest to start with whether or not we can determine the reduction potential for this cell first. So if E naught for the cell equals E naught for the reduction potential at the cathode minus E naught of the reduction potential at the anode. And what we need to recall is that this has to be positive. For the spontaneous reaction, the reduction the E naught for the cell should be a positive number. So let's look at the two reduction potentials we're given, 0.771 volts and negative 0.13 volts. If we were to put negative 0.13 here and subtract 0.771, we're going to get a negative because we're going to have a negative minus a positive, which is definitely going to be a negative number. So we can't do that. So we need to do it the other way. Said another way, this must be the cathode. And at the cathode, reduction is occurring. Said another way, this reaction is occurring as written. This must be the anode, and here oxidation is occurring. So this reaction isn't actually occurring. What's actually occurring is the reverse of this reaction, where electrons are being lost, not gained. So these are reduction potentials, so in both cases electrons are gained, or said another way, both cases electrons are on the reactant side. However, what's actually occurring is the reverse reaction of this, or oxidation is occurring. So we can plug these in now. We can plug in 0.771 volts minus negative 0.13 volts, and now to two decimal places we get that the reduction potential for this cell is 0.90 volts. So that allows us to figure out the end of this, and of course yes is the answer because it is possible to determine that, so then we actually determined it as 0.90 volts. Now we need to write the balanced equation for what's happening at the cathode. Well, this is pretty straightforward because at the cathode, this is the reduction potential for the cathode, so it's going to be Fe3 plus, aqueous plus an electron yields Fe2 plus, aqueous. So that was pretty straightforward. However, at the anode, this is not the reaction that's occurring. What's happening is the reverse of this reaction, because it's really oxidation. It is not reduction. So this is written as reduction, but we actually need the oxidation, so we need the reverse, which is CrOH3 solid plus 5OH minus aqueous yields CrO4 2 minus aqueous plus 4H2O liquid plus 3 electrons. So now we've got those. What we ultimately want to find is the overall balanced chemical equation. So just like before in previous problems on this playlist, we need to add these things together. So we have Fe3 plus aqueous plus an electron yields Fe2 plus aqueous, and this is our reduction. And then for oxidation, we have CrOH3 solid plus 5OH minus aqueous. Oops, I'm going to just straighten that out a little bit. Yields CrO4 2 minus aqueous plus 4 waters, which is a liquid, plus 3 electrons. Now, in order to add these together, we need to make sure we're not going to have any electrons in the system. So basically, we're trying to solve this middle problem here, the balanced overall equation. So these are the two reactions that we have. So how are we going to do that? Well, we don't want any electrons, so we need to have 3 electrons from this one to match the 3 electrons on this one. So essentially, the first thing we're going to do is put a 3 in front of all of those. Now we're going to add the reactions together. Remember that when we add reactions together, we simply write everything on the reactant side and everything on the product side of both reactions on the product side. So in this case, we're going to put 3Fe, 3 plus, aqueous, plus 3 electrons, plus Cr, OH, 3 solid, plus 5 OH minus, aqueous, yields, now the products, 3Fe, 2 plus, aqueous, plus CrO4, 2 minus, aqueous, plus 4 H2O liquid, plus 3 electrons. Cross out anything that's on both sides. In this case, all that's on both sides is the 3 electrons. Rewrite 3Fe3 plus aqueous plus CrOH 3 solid plus 5 OH minus aqueous yields 3Fe2 plus aqueous plus CrO4 2 minus aqueous plus 4H2O liquid. So now we have the overall reaction that is occurring, and that's what we could plug in right here. Note that before we added the reactions together, we did need to get the electrons to balance out so that they would cancel out, because in the overall reaction we do not want to include the electrons.